Assalamu alaikum wa rahmatullah. Hi everyone. We will be looking at a second suggested question for question 2 from the coverage of grade 11 elite. I hope these question numbers are not confusing for you, because we are doing question 2 from the coverage, and this is the second suggested question for question 2. We did question 1 in the previous video. Now this is the second question. We are given a function that includes an absolute value, and there are 3 parts to answer. This is going to be a quick question. We are given that f of x equals the absolute value of x minus 2 over x minus 2. And I always say, and I mentioned this many times in the class, whenever we have an absolute value, we can convert it to a piecewise function and get rid of the absolute value. So, how do we do so? Now, what does that mean, the absolute value of x? It means that if x is positive or 0, there is no need for the absolute value. Because if it's 0, it remains 0. If it's positive, it remains positive. But if the x is negative, yani less than 0, the absolute value makes the negative thing positive. So we have to multiply it by negative in order to make the same action on the x value as the absolute value. So what do? We did this many times actually in the class. So we will write this function as a piecewise function. So we know that the absolute value of x will be the same as x for x is bigger than or equal to 0. Yani if x is 0, the absolute value of x will be the same as x. If x is positive, bigger than 0, the absolute value of x will be the same as x. Okay? And then we will write this minus 2 over x minus 2. Now, but notice that 2 makes the denominator 0, so x should not be 2. X should not be 2 because it will make the denominator 0 and the function will be undefined. Now, what if x is negative? Yani if x is less than 0, with the absolute value of x, we can replace it with minus x, because the absolute value of x and minus x are the same for x is less than 0. Yani if x is equal to negative 5, you will put the negative 5 here, the output will be 5. I'm referring to the absolute value only. Okay? Right. If x is equal to negative 5, and there is a negative x, negative 5, the output will be what? The output will be 5. So for any negative number less than 0, the absolute value of x, it's the same as minus x. Okay? And then what do? We will write the rest of the function. Don't forget it. The rest of the function is minus 2 over x minus 2. So we removed the absolute value sign, okay, and we converted this function into what? Into a piecewise function. And we can simplify further actually. So f of x equals, now we can cross out x minus 2 with x minus 2. That leaves us with 1 for x is bigger than or equal to 0, but again x shouldn't be 2. Okay? And do you think we can simplify in the second one? Well, I don't think so, because x is negative on top, x is positive down. We cannot simplify it. So let's keep it as minus x minus 2 over x minus 2. This is for x is less than 0. Okay? By the way, we haven't started doing A, B, C, and D yet. We are just rewriting the function. Okay? Now we can get started. So it says part A. 1 minute. Here. No. Part A. Find all the zeros of f. All the zeros of f. What does that mean? We need to set the function equals to 0 and solve it. So if you set the function equals to 0, okay, and solve for x, you know that the denominator cannot be 0, because if the denominator is 0, it will be undefined. So it's only the numerator that can be 0 in this case. That means the absolute value of x minus 2 equals to 0, and get the 2 to the other side. So the absolute value of x equals 2. By moving the minus to the other side, it becomes 2. The absolute value of x equals 2. That means what? X can be 2, or x, it can be minus 2. But we said we don't need x to be 2. X cannot be 2. So this is out. We just need this one. So what are the zeros of f? X equals minus 2. The zeros it's just what? X equals minus 2. This is part A. Now what about part B? It says find f prime of 1. Okay, how do we find f prime of 1? So, what's that? Where is this color? Make it equal here. Okay. Well, 1 satisfies this here. Okay. 1 satisfies this condition. Okay. And f of x equals 1. That means f prime of x will be, what's the derivative of 1? 0. So f prime of 1 will be 0. Because f of x, it's equals to 1. And the derivative of 1 is 0. For x is bigger than or equal to 0. Okay? But for part C, you need to find f prime of negative 1. Right? Okay, f prime of negative 1, because negative 1 lies here, we have to differentiate this. We have to differentiate this one, right? We have to differentiate this subfunction. So, how do we differentiate this one? We can differentiate this one by using the quotient rule, because it's a quotient of two functions. So we will have f prime of x, okay, for x is less than 0. We have the denominator squared, and here we have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, which is 1. And we need to find what? Without simplifying it. Don't simplify, you just need to find a number at the end. So f prime of negative 1. So this is negative 1 minus 2 times minus 1 minus negative 1 minus 2 times 1 over negative 1 minus 2 squared. So f prime of 1, if you type this in your calculator, f prime of, negative 1, it will be 4 over. Sorry, there was a problem in the previous recording, so I've recorded a new one and I combined them in this video. So we were at part C. We found f prime of negative 1 by using the quotient rule, and then we substituted x equals negative 1, and we ended up having 4 over 9 for f prime of negative 1. For part C, is find the range of f. And the range is always associated with the y-axis, so the maximum y value and the lowest or the minimum y value for the function. Now if you look at the function, our function is a piecewise function and it's equal to 1 for x is bigger than or equal to 0, excluding the 2 of course. But if you look at the graph given by the answer key here, so for x is bigger than or equal to 0 here, the function is always 1, excluding the 2, the function is equals to 1. So this is y equals 1, and this is what? This is the upper y value. This is the upper y value. Now if you look at the function as for x is smaller than 2, for x is smaller than 2, the function is not constant, right? It's minus x minus 2 over x minus 2. Minus x minus 2 over x minus 2. This is for x is less than 0. Okay? But what is the limit as x approaches negative infinity here? Okay? We will be looking at the ratio of the leading coefficient because they have the same degree. So the degree here is 1, it's 1. So we will look at the ratio of the leading coefficient, negative 1 over 1, which is negative 1. So at negative 1 we have a horizontal asymptote, right? We have a horizontal asymptote at negative 1. Okay? Notice that the function approaches y equals negative 1, but it's never equal to negative 1. So the minimum y value or the least y value here, the lower y value, is y equals what? Negative 1. So we go from negative 1 to 1, but the function can equal to 1, and of course it's equal to 1, but it cannot be negative 1. So for the range of this function, we can say that y is bigger than negative 1, and it goes up to 1, including the 1 of course. So this is how the answer is represented in the answer key, and this is how you can write the answer. Okay, but please don't only write the inequality for the range. Okay, show that how did you get this as we discussed on this graph. That's it for the second question. Good luck.